To discuss about plane of symmetry. This symmetry element will be generated by doing the reflection through a plane. The operation is reflection. So the plane which can bisect the molecule into two halves, which are mirror images to each other. If we take the water molecule, so as I said, it is a V-shaped molecule, right? So if I put the mirror image like this, it is bisecting the molecule into two halves, right? So this is one half and the remaining one is one half, right? So this part will reflect at left side and this left side part will be reflected at right side. Okay, if you see the model, if I put the mirror image like this, okay, this half part will reflect at a left side. Again, the left part will reflect at a right side. Okay, so this is the original configuration and we will give the equivalent configuration by doing the reflection. Again, by doing reflection, it will give the identical configuration to the original one. That means the two consecutive sigmas will give the identical configuration. So here 1 and 2 are equivalent to each other, 1 and 3 are identical configuration to the each other. So the planes can be divided into three types based on the relationship with the principal axis. So one is vertical plane of symmetry can be represented with sigma v, dihedral plane of symmetry can be represented with sigma d, horizontal plane of symmetry can be represented with sigma h. Vertical plane of symmetry. The vertical plane of symmetry can be defined as which passes through or along with the principal axis. Can say it as vertical plane. For example, if we take the water molecule, the principal axis passing through oxygen atom like this, right? So this is called C2 axis. Okay, this is C2 axis of symmetry. If I put again the plane along the principal axis, which bisecting the molecule into two halves. If I put the plane like this, right? So half of the part will reflect here, half of the part will reflect here. So this plane is possible through the principal axis. So it can be considered as sigma V, right? And if you see the another plane, molecular plane, the molecular plane is which bisect all the atoms into two halves can be considered as sigma v here because it is passing through principal axis. Principal axis is like this, right? So if we put the plane, if it is, we assume if it is plane, so it bisected the molecule into two halves, right? So below part will reflect at upper part will reflect at down, right? So this is the plane which is bisecting the all the molecule into two halves, right? So if we use like a plane, it is bisecting all the molecule into two halves. Got it? So this can be considered as a sigma v. I am taking the ammonia molecule as example. Ammonia having the formula NH3 and it's a fifth group element. The three hydrogens will place and again one lone pair will place like pyramid shape on the nitrogen atom. If you see in the model, three hydrogens were placed like this and if it is nitrogen and this is lone pair of electrons, right? So it is ammonia. So again here the axis is passing like this. So angle of rotation is 120. So by doing 120 degrees rotation, we will get the equivalent structure. Okay. And the plane is possible through one of the hydrogen and lone pair of electrons like this. Okay. Like these three planes will possible and they maintains the relay passing through the principal axis. If you see in diagram, nitrogen, hydrogen, H1, H2, H3, right? So on nitrogen here lone pair of electrons will present. If I put the plane like this, okay, so H2 will reflect here, H3 will reflect here. So each sigma is passing through hydrogen, nitrogen and lone pair of electrons. Like that, each hydrogen, each plane is possible. Through each hydrogen, one plane is possible. So like that, 3 sigma V will possible. In ammonia, the principal axis is C3 and the P3 planes will possible. They can be considered as sigma V, vertical planes. And the two planes will possible through 2 hydrogen atoms and 3 carbon atoms like this. If I put the plane like this, okay, so it is passing through the atom and emerges through in between these two hydrogens, right? So this will reflect here and this will reflect here, right? Again, another plane is possible through perpendicular to origin, first one, right? If this plane is passing through like this, again it exits here, bisect the molecule like this, okay? So upper will reflect at down, down will reflect at upper, okay? If you see the diagrammatical position, so if it is front carbon, it is back carbon, this one is the middle carbon, right? So the two C2s will placed like this. So these two are consecutive, right? So the angle is dihedral angle. If we placed the plane through two hydrogen atoms and three carbon atoms, these two will reflect each other. If we pass a plane again like this, these two hydrogen atoms will reflect to each other. C2 axis passes through the central carbon atom, right? So each sigma D is coplanar with 3 carbon atoms and H2 unit. 3 carbons and H2 unit. Like that, this plane is bisecting the dihedral angle. So we are considering here the plane as dihedral plane. In allele, there is 3 C2s possible and 2 sigma Ds will possible. Now, horizontal plane of symmetry. The plane which is perpendicular to the principal axis is called horizontal plane of symmetry. So here I am taking the BX3 example. So it is having trigonal plane, right? As we discussed, the C3 axis is passing through like this. If it is trigonal plane, the axis is passing through perpendicular to the plane. Okay. So I am rotating the molecule like this. Okay. If we see the model, so if I put the axis like this, I am rotating the molecule like this. Okay. About 120 degrees, we will get the C3 principal axis of symmetry, and through one of the halogen and boron we will get the 3 C2s, C3 and 3 C2s, right? So here if the principal axis is like this, so it is a planar, right? So if we bisect the molecule into two halves, that is this plane is bisecting all the atoms in the molecule into two halves, is said to be molecular plane. So half of the part of the model will reflect at down, down will be reflect at out, right? So and this plane is perpendicular relation to the principal axis. This plane is perpendicular relation, right? So it can be considered as sigma h. Here I can take trigonal bipyramidal as the example. If it is PCl5, okay. So trigonal bipyramidal shape. Trigonal angle is here and these two placed like bipyramidal. So axis will pass through, the principal axis is passed through like this, two axial atoms, right? So the angle of rotation is 120 because it is triangular plane, right? So if I pass the principal axis like this, if I put a plane which is bisect the three equatorial atoms and central metal atom, right? So if I put the plane like this, if I put the plane like this, okay, it bisect these three equatorial chloride atoms and phosphorus atoms and this one into two halves, right? So the axis is perpendicular to this plane. So it can be considered as sigma h, right? So the plane is considering only three equatorial and platinum. It is going like this. So in between the atom. Okay, so that this upper part will reflect at down, down part will reflect at up. Axial atoms will reflect to each other, right? So it can be considered as a sigma h due to perpendicular relation to the principal axis.